Okay, class, today we're going to talk about solving quadratics with imaginary solutions. So first, I want to go over something with you so you can remember. Remember, we have different types of solutions. On the first example here, you see that it's touching in two spots. Because it's touching in two spots, we have what we'll refer to as two solutions. Then if we look down at this one, it's touching in one spot. So this is one solution, or what we've called and you'll hear it often referred to as a double solution. It's just the same double solution. Now on this one here at the bottom as well, I'm still touching, even though this one is going down and it has a max and this one is going up and it has a min, I'm still touching in two spots. So I have what? That's correct. I still have two solutions. Now let's look at this one up here. Remember, the solution of is always where I'm touching the x-axis. So as we look at this one up here, where am I touching? Nowhere. That's correct. So up to now, we've been saying what? We've been saying that there are no solutions. Right? Okay, but that changes today, because now we have what's called imaginary solutions. So that introduces us to this assignment, which is on solving quadratics with imaginary solutions. So we're going to focus on the top half. Don't even worry about 5 on. We're going to focus on 1 through 4. So an imaginary number is defined as to be at the square root of -1. So let's talk about that a little bit more. Okay, so let's talk about the square root of -5. We know that this is also considered the square root of -1 times 5, correct? So we can separate that negative, which we did a lot when we were doing factoring. We did the factor tree. So I can separate this and say the square root of -1 times the square root of 5, correct? Well, according to the sheet, the square root of -1 is what? I. So this really says I, the square root of 5. Okay, let me talk a little bit why this is. Because you will hear it said that the square root of -1 is really the square root of I squared. And the square root of I squared is what? It's just I. So make sure you understand that connection. So now we're going to do the second problem, and I'll show you your sheet. We just did the first one, to which we got I square root of 5, correct? So I'm going to go back to the other sheet to do the square root of -25, just so we have more room. So now I have the square root of -25. So I'm going to separate those just like I did the other one. So that's really what? The square root of -1 times 25, correct? So I can separate both of those into the square root of -1 and the square root of 25, correct? Now, because we know that the square root of -1 is really the square root of I squared, we can separate both of those. What's the square root of 25? 5. And what's the square root of I squared? I. So I really have I times 5, correct? But remember, in algebra, we would write this as 5i. So in looking back at our other sheet, we should have that equals to 5i. Okay, now let's do the next one. Now we have the square root of -45. So I have the square root of -45. Well, this one's a little bit different because I always want to separate it by something perfect, right? And I know there's a 9 in there. So that's really the square root of negative 9 times 5, correct? Well, I don't want that negative attached to anything. So I'm going to say that that's really the square root of negative 1 times 9 times 5. Are we good? So what I'm going to do now is I'm going to write each one of them under its own radical. I have the square root of negative 1 times the square root of 9 times the square root of 5. Well, if I separate them, I know the square root of negative 1 is I, the square root of 9 is 3, and the square root of 5 isn't perfect, so it's going to be the square root of 5. So when I rewrite that, I'm going to rewrite that as 3I, the square root of 5. So I'm going to go back to my other sheet, and I'm going to make sure I put that that is 3I, the square root of 5. Okay, let's do the negative 180 now. So I know I have the square root of negative 180. Well, I know that there's a 9 in there. So if I do my factor tree, just so you can see what all you can take out, I know I would have a 9 times 20, right? But is there anything perfect in there? I'd have a 4 times 5, which is perfect. So what I could do is I could say, well, I could also say, well, I have a 36 in there. Let's talk about that, because I know sometimes that's difficult for y'all to see. So I'm going to, on this one, do a factor tree so you can actually see where I'm getting these numbers. So if I do a factor tree, I know that I'm going to have 2. Keeping in mind, I know I have a negative 1 over here. 2 times what? 90. I circle 2 because it's prime. And then I'm going to have 2 times 45. I circle 2 because it's prime. 2 won't go into 45, but I can take 3 into it 15 times, correct? Circle 3 because it's prime. And then I have 3 times 5. Circle them both because they're prime. So then I'm left with 2 times 2 times 3 times 3 times 5, correct? Remember, you need 2 pair of something to take it out. You got to have 2 pair of something. Okay, so what that gives me, I said, was a pair of 2's and a pair of 3's. Remember, that's what you need to pull something out. So the square root of that will give me 2. The square root of that will give me 3. And 3 times 2 is 6. So I know that I have 2 6's in there, which is why I know that I can take this and say, okay, I have the square root of negative 1 times 36 times 5. Are we good? So that would give me, if I separate them, the square root of 1. Let me rewrite that, guys. I'm having a little pen issue here. Okay. That would give me the square root of negative 1 times the square root of 36 times the square root of 5, correct? Well, the square root of negative 1 is what? That's correct. It's just I. The square root of 36 is 6, and the square root of 5 stays the square root of 5. Well, we always have to write that like we write algebraic terms, so it's going to be 6I, the square root of 5. Any questions over that? Okay, class, here's 3 examples I want you to work and have ready for me in class tomorrow. Number 1 is the square root of negative 72. Number 2 is the square root of negative 24. And number 3 is the square root of negative 169. So go ahead and take a moment and work these on your own, and we'll go over them in class. I hope you have a good evening, and I'll see you tomorrow. Have a good night. Bye-bye.